All right. Algebra 2, lesson 48, understanding complex fractions. What I want you to understand is that we're not changing the rules to fractions. Okay? If I want to add two fractions together, what do they have to have before I begin? A common denominator, right? Okay, what do I want to do? What did I just say add? Or did I say subtract? I said add. Okay? If I want to subtract two fractions, I still have to have a common denominator, right? What if I want to divide a fraction by a fraction? What do I have to do? Can I divide by a fraction? I have to multiply by the reciprocal. Those are really the three things that you need to know. All right? Common denominator, multiply by reciprocal. Right? It doesn't change just, and whenever we say complex, it means that we're swapping out numbers with letters. Right? But it ultimately doesn't change the rules. The rules still exist. Okay? It's just a part of algebra that people don't like whenever you start swapping out numbers with letters. So a complex fraction is still a fraction that contains one or more fractions in its numerator or denominator. Okay? Some examples of complex fractions are here. We have x minus 2 divided by 5 divided by x. Now, if I was going to solve something like that, I would start off with x minus 2 over 1, because any number is a fraction over 1. Do we understand that? Okay, so I would take x minus 2 divided by 1, and I'm going to multiply by the reciprocal, x over 5, right? So now I distribute the x, and so my answer comes out as x squared minus 2x over 5. Now I've got it down to just a single fraction. Does that make sense? Do we see what we did there? All right. Now, same thing here. I've got 2 plus 1/3 over 2x plus 5. So the first thing I see is that 2 is a fraction over 1, right? I need to get a common denominator, and I'm dividing by 2x plus 5, which is also a fraction over 1, right? So these are just meant to show you examples. So I would get, I'd get a common denominator. I'm going to multiply this by 3 over 3, right? That's going to give me 6/3 plus 1/3, which is 7/3. And I'm going to multiply by the reciprocal. So I'm going to multiply by 1 over 2x plus 5, right? Does this make sense? Am I going too fast? Okay. 7 times 1 is 7, and I distribute the 3 to the 2x plus 5, right? 3 times 2x is 6x. 3 times 5 is 15. So my final answer is 7 over 6x plus 15. Is this making some sense? I'm really not doing any new steps here. Okay, common denominator, multiply by reciprocal. Okay, now this next one over here takes all that and does it in both the numerator and the denominator. Okay, meaning that I need to look at this as x over 1 and look at this as x over 1. I need to get a common denominator between the fractions in the numerator and a common denominator between the fractions in the denominator. Simplify both those fractions and then multiply by the reciprocal of the denominator fraction. Did I say that too fast? Or do we understand? Somebody understands? Okay. Let's go on to some more of the notes, though. Okay. So method 1, simplify as needed to write the numerator and the denominator each as a single term, then divide. And that's what we've done through there. Okay. Make sure that everything can be written as a single fraction in the numerator, a single fraction in the denominator. Okay? I think we showed that at least on the first two. And that's really what we're endeavoring to do on this third one. What am I going to have to do here to get a common denominator? X over x here, which is going to give me x squared plus 2 all over x, right? But that's a single fraction now where it wasn't before. Okay? Down here, what do I have to do to get a common denominator?
3x.
Multiply by 3x over 3x. Okay? So what's 3x times x?
3x squared.
3x squared. Okay, minus 1 over 3x. And so one of the things that I do, just so that I don't actually have to rewrite everything, is that I understand that really I'm going to multiply this, the complete top by the complete bottom, and then the two middles, right here, those things are going to multiply. So I can usually go from there. Now, we're not necessarily going to solve all of that, but we could, right? Method number 2 is multiply the numerator and the denominator by the least common denominator of all the fractions in the complex fraction, then simplify. But I tend to lean on method number 1. Okay? Because when we start trying to find the least common denominators between everything, then it can really kind of start to get. Okay, somebody might say it's already confusing and complicated, but that's all the notes. Okay? Just that. So, I don't know, it doesn't look like I have it, so let me pull it up. I apologize for not being on the ball as much today as I usually am. All right, lesson 48. Opening an existing text. Here we go. All right. So we got this right here. Okay. If I want to simplify this, what do I need to do or add to it first? Put 2 over the value of 1 there. Okay. Anything else I can do before I really start to put 9 over 1 as well? Does everybody get and understand that? Okay, that's going to help me understand that I need to get a common denominator whenever I start to write off whole things as fractions. Even if it's a variable over 1. Okay, so let's go to the numerator. What do I want to do with the numerator? Get a common denominator. What is the common denominator? It'd be a, and how do I get a in the second fraction? Multiply by a over a. So let's go ahead and rewrite now that numerator fraction as just a single fraction. What is that?
11 plus a.
11 plus
2a.
2a, because we are distributing the 2 and the a, all over a. Okay, good? All right. Now what about somebody besides Eric for the denominator? Allison?
B over b.
On the 9 part of it, right? Okay, so help me rewrite the denominator for the whole. Go ahead.
5 plus b over b.
All over b. Okay, so I have 11 plus 2a over a divided by 5 plus 9b over b. John, what would you do next? Cross out the a's and b's. Nope, no, I wouldn't cross out the a's and b's. Multiply by the reciprocal. So if we have to, and it might help to go ahead and write it anew, write 11 plus 2a over a, and I'm going to multiply by the reciprocal. So John, what am I multiplying by? What's in the numerator? I'm multiplying the blue fraction, the top numerator fraction. I'm multiplying by the reciprocal of the denominator fraction, the red fraction. B, okay, over 5 plus 9b. Okay, so multiply across the top. So what are you getting then?
11 plus 2ab.
Close. No parentheses needed, but you didn't distribute the b to the 11. Okay, so that should be 11, right? Because I'm multiplying that b into each of those two terms, right? All over what? Because I did it with the numerator. Now I need to do it with the denominator. So 5a plus 9ab. Good. Okay. So we can go up here. Looks like B is my answer. Does this make sense? Okay. We're actually going to skip number 2. I disagree with number 2's answer in here. So I've seen it on a test. If I see it on your next test, I'm going to throw it out because I disagree with their answer for it. All right. So this looks pretty complicated, right? Yeah? Okay. Let's see. So you guys have this up on your page, right? So what I'm going to do is I'm going to pull it up on one of our blank pages where we can actually show a lot more work. And I'm going to have you repeat this question back to me so that we can work it. Okay. All right, so what's in the, I have a fraction in the numerator, right? I actually have two fractions, right, that I'm adding. Okay. What's the first fraction, the one to the left? Negative 5 over x minus 4. Okay. And then plus
Negative 6 over 10. X minus 6 over 10.
x minus 6. Okay, so like this over 10. Okay, and in the numerator, or sorry, denominator. X plus 3 over x minus 4. Okay. So there's only one fraction in the denominator. Can I simplify the denominator fraction? The x plus 3 over x minus 4. Can I do anything with that? No. Okay. But looking at the set in the larger numerator, the negative 5 over x minus 4, the plus x minus 6 over 10, right? I can combine those things and should get them simplified down to one fraction, right? The rules haven't changed. What do I have in order to add them? I have to have a common denominator. It looks complicated, and so rather than try to guess at what the common denominator is, what can I always do? Anybody? How can I always get a common denominator? Even if it's not the most simple common denominator. Even if it's not the least common denominator. Could I can multiply, yeah, you're right, I can multiply them, but multiply them specifically so that I'm multiplying each of them by the other side's denominator, right? So this by x minus 4 over x minus 4. Does that guarantee me that I will get a common denominator every time? Yeah. Okay. Does this make sense? Do we see what's going on here? All right. Now, does that make it a little tougher up here, to the right? Yeah, because what am I going to do with this x minus 6, x minus 4? What's that going to become? What am I going to have to do to multiply those? I'm going to have to FOIL them, right? So we don't want to do something like that because it's a lot more work, but sometimes I'll just be honest with you, the right way of doing things is a lot more work, okay? So let's write it. We got x plus 3 on the bottom. We got x minus 4 on the bottom. All right, what's negative 5 times 10? Let's just take it one step at a time. Negative 50. Okay. All right, and at least as far as this goes, we can really leave this as 10 times x minus 4 until we can't do anything else with it. Okay? All right. Let's see. So x times x is x squared. Okay, and in fact, what I'm gonna do, honestly, is I'm gonna leave this as plus x minus 6, x minus 4. I'm just gonna leave it like that. Do you know why? Because at least right here, I can cancel out the x minus 4. Do we see that? Okay, I'm not saying it's going to work out for us like that every single time, but here it does. So now I have negative 50 plus x minus 6 over 10 divided by x plus 3 divided by x minus 4. So this is my simplified numerator. And can I still simplify this a little bit further? What can I do there? Negative 50 minus 6, which is going to be x, so I have x minus 56, right? Okay. And I'm going to multiply that by what? No? X minus 4 over x plus 3. Okay? All right. So now here, I'm back to foiling again, right? Because it's x minus 56 times x minus 4. Okay, so I have x squared. I've got negative 4x minus 56x. And then 200 what? 224 all over really 10 times x plus 3, right? Okay? And I'm going to come down because we're going to see if we can't simplify this. Okay? So x squared, that's going to be what? Minus 60x plus 224 all over 10 times x plus 3. What I'm interested to know is, can we simplify that up there? You know, can we factor that, okay, into anything smaller? Okay, notice this is a minus and this is a plus, so it'd have to be x minus, right? Okay, so I'm going to guess maybe not. I don't know other things that, the only things I can think, things that add up to, here, let me hit pause. All right. Hey, let's get back to this, guys. Okay, so let's see. Looking at this, I think probably one of the mistakes being made is that we went ahead and we canceled out those x minus 4s right off the beginning. I think rather than doing that, probably one of the things that we want to do is keep it so that we are getting, you know, we have the negative 50, but we're getting plus x squared. We're going to get, with that, we're going to get negative 10x, and we're going to get what, positive 24 over 10 times x minus 4 times x minus 4 over x plus 3, right? At that point, right, what we're going to see is from here we see the x minus 4s cancel out. I'm still trying to find out what happened with the, oh, okay. With here, right, between this, that negative 50 and that positive 24, that's going to come out to negative 26. So you get that x squared minus 10x minus 26 over, oh gosh, let me find it here. Oh, over 10 times, yeah, because you're getting that right across here. So 10 times x plus 3. So we canceled out the x minus 4s too early, right? We want to leave those. Go ahead and get that FOIL, combine that negative 50, right? So sorry about that. It's what I try to do whenever I'm doing stuff off the top of my head. All right, let's try to get, well, you guys are out of here, what, 1048, or is it 1036? 36. Let's try to look at least at one question from your book. Let's see, we're at 48. So why don't you guys pick one out? Which one? D? Oh, of course, always D. Okay, but it's not a bad question for you to look at because it does give you, it gives you an equation for finding the area of a regular insided polygon. Notice that it says area equals 1/2 NAS. Okay, so N should be number of sides it has. A is the length of the apothem. The apothem is the distance from the center of a regular polygon to the side, and it should be a perpendicular length times the length of a side. Okay? So it says the Pentagon building in Washington, D.C. has the approximate shape of a regular pentagon. In a regular pentagon, the apothem A and the side length S are related by the fact that the apothem equals the side length divided by 2 divided by 0.727, okay? Where 0.727 is correct to the nearest thousandth. Express the formula for the area of a regular pentagon in simplest form in terms of S. All right. So basically what we're saying, if area equals this, right? We got area equals 1/2 times the number of sides, right? Which in our case is how many? How many sides are in a pentagon? 5. So we know we have this times the apothem, which we know to be S over 2, divided by 0.727. 0.727 times the length of a side. Now, they haven't given me the length of any of the sides, so I'm trying to simplify that on down. Okay? That's what they're looking for, is that simplified. Okay? So sorry we didn't get into it a little bit further, but that at least gives you a beginning and lets you know what those different variables mean and how to set it up. Does that make sense? What's that? That should be an S. Because it says in a S. So yeah, that's an S at the end. The only 5 in here is this 5 next to the 1/2. So you could even go ahead and change that and get A equals 5/2 times S over 2 divided by 0.727, which is really divided by 1. So you're seeing here that I can multiply by reciprocal times S again. All right, so we're starting to see how this is going to be done. Okay. All right, let me hit stop there.